Hi everyone. Today I'm going to be sharing with you a project that we've been working on for the past couple of years called content orchestration. This is really our kind of first foray into the world of reinforcement learning for personalization. So it's been a huge learning experience for us, and hopefully I'll be able to share some of those key takeaways with you. So quick overview of what I'm going to cover today. I will start with a bit about data science and Tesco, but then we'll jump into the main content, looking at content orchestration, the models we're using, some test results, ongoing and future work, and finally, if everything goes according to plan, we'll have some time for questions. So yeah, starting with some data science at Tesco. So just a quick mention to start off, most of the stuff about Tesco here has come from an article written by our Director of Data Science. I can't really share like a link here, but hopefully this kind of headline is enough for anyone to find it if you're interested. So hopefully everyone is familiar with Tesco. If you're not, we're a retail company selling mostly groceries, but some other products. We're the largest supermarket in the UK, but we are now based across a wider area than that. We have nearly 5,000 stores and over 300,000 colleagues. And we're now mainly the UK, but also in Republic of Ireland, Hungary, Czech Republic, and Slovakia. So the data science team at Tesco is responsible for a whole bunch of things, personalizing search and recommendation events, optimizing delivery schedules, handling online orders, optimizing thousands of truck routes between depots and stores, and also handling price reduction models. That's the yellow sticker reductions, which everyone loves. So we do a lot of things, but it hasn't always been this way. If we go back just 10 years, data science team didn't really exist the way it does today. There were perhaps a handful of people just doing some interesting kind of deep dive analytics on our huge amount of data. It was about 2016 where the data science team really got formalized, but it was still about 10 people and still very much in the realm of researching some interesting problems. Fast forwarding about 7 or 8 years, we are now a team of about 160 going on 200 people developing productionized AI software products. And we're now made up of data scientists, data science engineers, machine learning engineers, and a few other positions. So Tesco Technology follows a product-led agile methodology. And then within that, the data science team is primarily responsible for developing the algorithmic features for those products, which are meant for supporting or automating the decision-making. So as I said, data science does a lot of things. We have a few kind of core facets. These are pricing optimization, intelligent edge, which is things like computer vision, personalization, optimizing operations, commercial decisioning, and forecasting. I'm happy to say that obviously we've grown a lot in the past 7 or 8 years, and we are still growing. So we are actively hiring at the moment. So if you're interested in finding out more about these positions, I'll show this slide at the end, but feel free to come and talk to us any point during the conference or reach out to one of our recruiters. So moving on to content orchestration. We can start off with the main question of what is content orchestration. It's a term used kind of in a variety of ways across many industries. When we look at Tesco, we can think of it this way. So if we imagine a scene on the Tesco website, this is from the groceries homepage. This is what we mean by content. So these big kind of tiles or stamps that you see on the website. There's one I left here, which is like fancy and ice cream. That's the kind of thing. Currently, all of the content on the website is static. So these positions A, B, and C, the content that appears there will be picked by a group of people every few weeks, and that decision is entirely manual. What we want to do with content orchestration is to make this content selection dynamic and personalized to the user. So we have our website, we have our content positions, and we have some users queuing up to see it. Instead of a static section of content, we now have content options. So maybe 3 or 4 options for this big stamp at the top and a few more for the smaller ones at the bottom. Content orchestration can really, in a nutshell, be described as the model in the middle that will pick the right content for the right slot for the right user. So in an ideal case, we might see something like this. So user 1 perhaps eats a lot of meat, and so we might want to show them meat-based content. User 2 maybe doesn't eat meat, and instead we found that they perhaps have some young children, so we might show them some back-to-school promotions. For a completely unrelated reason, they might also like a glass of wine or two in the evening. So we might also show some alcohol recommendations. Why do we actually want to do this, though? Obviously, there's going to be some big drawbacks to showing static content on the website. One of these is limited content diversity. There are only so many slots that we can place content on the website, and things at the top will have higher exposure than things at the bottom. So there's a constant battle between different pieces of content as to what's going to get shown. And this does end up leading to a reduction in diversity. Kind of on the back of this, we end up with irrelevant content. If we're showing those meat kind of related contents, people that are vegetarian, vegan, or for whatever reason don't eat meats aren't going to engage with that content. And really as a company, we want to strive to be providing content that is useful and engaging to all of our users. Kind of extra impact here is that if we are showing a limited selection of content, we can end up inherently causing a bias in that content. If we have a group of users where we think content is widely appealing, there's going to be another set of users who aren't going to receive content. Finally, and perhaps as a result of these two, we have seen relatively low engagement in the content. Tesco, hopefully unsurprisingly, does have a relatively high amount of traffic through the groceries website, and this then corresponds to a large number of user impressions or views on that content. Yet, unfortunately, in many cases, we do see fairly low engagement in that content. So by personalizing this, we really want to do three things: improve diversity, relevancy, and engagement. We can then kind of formalize this into a problem statement. So our objective here, hopefully clear by now, we want to choose the piece of content that has the highest probability of being clicked by a user. We have a couple of kind of resources we can use to help in this decision making. We have the customer purchase history, which is essentially the set of products that a customer has bought historically. And we have the user interaction data. So this is essentially the record of what you've viewed and what you've clicked on the website. A key assumption here, or perhaps just a sad reality, is that whatever model we choose at this stage, it's going to be unaware of what the content is. So these options on the right here, the model is not going to know that the top left one is kind of meat-based or the top right one is fruit. This is not something that's impossible to do, just not something we have the ability to do right now. So how do we actually do this? Contextual bandits. There are a bunch of different models that we could have gone with here. We have chosen to go with a contextual bandit approach. So contextual bandits are a form of multi-arm bandit. The term bandit originates from a gambling term, so sometimes slot machines and casinos are referred to as bandits. Again, I suspect most people know what a slot machine is. For those that don't, it's a so-called game where you pull a lever and you normally lose money, but every now and again you might win some money. Your objective, of course, playing this is to win as much as you can, but perhaps if you're secretly a data scientist playing this game, you might have a little side task of trying to figure out what your probability of winning is. For multi-arm bandit, we can scale this up to, instead of one slot machine, having a row of slot machines, where the probability of winning on each machine is different. Being a data scientist now becomes a little bit more useful because winning is not so easy. We now need to find a kind of trade-off between exploring the different machines and figuring out our different probabilities of winning versus playing the machine that we think currently gives us the best payout. Multi-arm bandits are exactly this. It's a model that automates the exploration and exploitation of your options, in our case, content. Many different multi-arm bandit models exist of varying levels of complexity, ranging from very simple algorithmic approaches up to essentially full-on neural networks. But obviously the common factor here is using exploration and exploitation, and in most of the cases, the kind of trade-off between these two is tunable by some set of parameters. Contextual bandits are essentially a slightly more advanced version of multi-arm bandits. The clue's sort of in the name. We add external information or context to the model. This is what really allows us to do personalization. A multi-arm bandit doesn't know who's trying to see the content, so it can only really pick up on global behaviors. If we instead are able to condition our model on some kind of user context, that allows us to take the user and personalize what content we show to them. In our case, this user context is derived from a purchase history. I'm not going to go into too much detail here. I think we actually gave a talk last year on our autoencoder model. But a kind of brief overview is we use an autoencoder model where the objective is to encode a user purchase history and then decode it back to the user purchase history. And right in the middle here is what we're interested in. We end up with what's called a latent space right in the middle of the autoencoder, and from this we can pull out essentially a numerical representation of our user. So I want to highlight quickly some of the similarities and differences between contextual bandits and the kind of traditional reinforcement learning model. They are similar in many ways. They both have what is called an agent. This is essentially the main part of your model that will make the decision or perform an action. And they both need either some kind of generic model or, in our case, a user that will look at the action that was taken and decide whether that was good or bad and produce a reward. In some cases, this is a binary reward. Other cases, it might be more complicated. The main difference then comes in the kind of observations or awareness that these two approaches have. In a typical reinforcement learning case, your agent is considered to kind of take an observation of its environment. If you consider training a model to learn to play chess, that observation might be looking at all of the positions of the pieces on the chessboard. Another key thing here is that when your model does make a move on that chessboard, its choice at any given time will impact that state of the environment. And so there's a continuous feedback of any choice it makes will impact the future choices. This is kind of where contextual bandits become slightly more, slightly simpler. First of all, our kind of environment doesn't really exist. Instead of an observation of this environment, we observe a user context. In addition to that, when we perform an action and pick a piece of content to show a user, there isn't really an impact on that user context. Over the long run, perhaps, but in the short term, there is no real-time feedback that will mean the agent changes its decisions time by time. So the model that we've chosen to implement here for our contextual bandit is the LinUCB algorithm. That's a linear upper confidence bound model. There's essentially kind of three components to this model. The first two I've shown here. So the way this model works is that we create an arm for each of our content options. So in this case, we have content A, B, and C. Each of those arms is initialized with a uniform prior. So all of the weights essentially get set to either an identity matrix or zeros. When it then comes to inference and we want to pick which piece of content to show to a user, the way we do that is by optimistically picking whichever arm has the highest upper confidence bound. We can construct this upper confidence bound out of two terms. First is our expected reward. This is essentially that probability of winning on the slot machine, or in this case, the probability of a user clicking the piece of content. The second term then is the uncertainty in that score. So you can imagine when we first start showing pieces of content, we don't really know how a user is going to react. But perhaps after a week or so of learning, we'll have a much better idea of that reward. We construct the upper confidence bound here by creating a linear combination of those two. So we add the expected reward to a scaled value of the uncertainty. We can visualize here with these kind of, this plot. So for each piece of content, we have the bar in the middle, which is our expected reward, and then the kind of height of that bar represents the upper confidence bound. So in this situation, even though content C has the highest expected reward, we would actually pick content B to show to the user because of the highest upper confidence bound. Now, I mentioned that we can tune how much we explore and exploit. So if we were to reduce alpha here, the effect that would have is essentially to shrink these bars. And so you can see that just with a small amount of shrinkage, we would probably pick content C because the uncertainty term would have become less significant in that calculation. We can look at this kind of from the mathematical perspective. Here at the top are obviously those uniform initializations with an identity matrix, some zeros, and we can also see now this X matrix, which is our user embedding. The second step then is our inference, and you can see here that the reward for each arm is, the score for each arm is constructed out of this expected reward term and a weighted version of the uncertainty term, and we will pick the arm that maximizes the combination of the two. Finally, the only step I haven't mentioned so far is how do we actually train these weights? This is the only aspect that doesn't really happen in real time. According to the kind of theory of the model, it should do, but due to constraints of just kind of infrastructure, we're instead opting for a 15-minute batch update. So we essentially collect 15 minutes of interaction data of whether users viewed the content, whether they clicked on it, and at the end of that 15 minutes, we perform the updates according to these rules to the weights in the model. Now, obviously, that's just a small part of the whole. Building the data science model, I would probably consider easy out of the rest of this. Needless to say, to produce a kind of real-time personalization, a lot of teams are involved. I'm not going to go through some detail, but we've got front-end, back-end, APIs, live streaming of events, a whole lot of work. So really, this is just to highlight the complexity and give a shout out to all of the teams involved to pull this off. Spoiler alert, we did pull it off, and we have run a successful A/B test. So this is, it is working, yeah. This is where we ran the test. So this is the groceries homepage. And as we scroll down, the tile that we were personalizing is this top left tile with the meat on it. You might already notice off the bat that this is not perhaps the best place to try and optimize user engagement, since you're trying to optimize engagement on a piece of content you only see if you scroll 2/3 of the way down the page. This is something that we just kind of had to accept, but we are trying to improve with future tests. So the way this test was set up, we ran an A/B test where the control was essentially a random baseline and our variance was our personalized model. Typically here, your baseline would probably be whatever your current implementation would be. So that would be the static version of the website. But we chose to implement a random baseline for kind of one main reason. If we showed the static view of the website, we would only have one piece of content shown to the control users. That would be great because we can compare the overall change in engagement driven by the personalized model, but we wouldn't be able to actually compare directly individual pieces of content and the impact that had. So by adding a random baseline where all of our content options are available both on the variant and on the baseline, we can compare both overall engagement and engagement on individual pieces of content. So we had 4 pieces of content to choose from here. So within that one tile, we could have shown 4 different options. The test ran for 6 weeks, and we refreshed that content at the midway point. So 4 pieces of content for the first 3 weeks, 4 pieces of content for the second 3 weeks. We did also refresh the model every week. We did this for 2 reasons. First of all, in a kind of live setting, the content on the Tesco website gets changed or at least shuffled about once per week. So were we to put this into production, there isn't really a relevant use case where this model would be running for more than a week at a time. Secondly, prior to running this A/B test, we weren't able to get any particularly useful insight into how to choose that alpha parameter, which is our explore-exploit trade-off. This is largely because we only had access to a fairly kind of bog standard offline evaluation, which when you're looking at a reinforcement learning approach, offline evaluation doesn't really work that well because the model kind of relies on that real feedback loop. So we had to rely on the A/B test to allow us to gain insight into how that alpha value impacted real performance. So first of all, we can look at some results on the impact on user engagement, since that was one of our kind of main motivations for this. And we do see some very positive results. So this is the results from the very first week of the test. We saw fairly similar things across the remainder of the weeks, so I'm not going to show them all, but we can see some interesting behavior here. So in blue, we have our personalized model, and in red, we have the random baseline. And on the left, we're showing cumulative clicks across a week. So this is essentially a measure of how users engaged with the content across a week. And we see for the first kind of 2 to 3 days, both the personalized version and the random baseline perform fairly similarly. This might not seem great, but actually it's pretty much what we expect, since this really shows the model is exploring. While the model doesn't explore completely randomly, it is based on uncertainty and user context and more. It makes sense that it's going to appear fairly similar to a random baseline, since the model is not trying to exploit the information it's gained. When we move on to the second half of the week, we do suddenly see a fairly substantial increase in performance. And after the end of this first week, we end up with a between sort of 30 and 40% increase in overall user engagement. We can see exactly the same thing measured as click-through rate, is obviously kind of inherently tied to the cumulative clicks, but just a different way of visualizing that. As I said, this is week 1. We saw similar things for the remainder of the week, so I'm not going to go through those. A different thing we can look at, though, which is perhaps provides a little bit more insight, is trying to look at the model behavior, particularly as we change this alpha value. So we can look at the extremes here of what we tested. Alpha equals 5 is a fairly unrealistic value. Typically, that should be somewhere between 0 and 1 for it to have any mathematical meaning. But here what we're doing is essentially forcing the model to be entirely explorative. So no matter how much information it learns, it will really never learn to, or never start to exploit that. And we see here some interesting things. So here, instead of plotting cumulative clicks, we're looking at cumulative impressions. So just how many times have these pieces of content been viewed by users. And each line here, you can't really see because they all overlap. There's 4 lines here, each one representing one of our content options. So I guess immediately you can see that they all are basically the same. And this is showing that the content was essentially evenly split across our entire audience. This makes sense because if the model is never exploiting any of the information it gains, it's never going to learn to show different pieces of content to different users. The other thing we see here, which is interesting, is a kind of, I've called this a sort of braiding or weaving effect. This is really indicative of exploration, but it's also an artifact of this kind of 15-minute batch updates we do. As I mentioned earlier, the way the LinUCB algorithm works is based on an upper confidence bound. So by setting alpha equals 5, we've essentially said pick content purely based on the uncertainty on that content. So when we only perform updates every 15 minutes, what we end up doing is right at the start, we'll pick a couple of pieces of content and show them to users for 15 minutes. As a result of showing that content for 15 minutes, the uncertainty for those pieces of content will drop drastically. When the model then actually learns the effect it's had and we update those weights, it'll suddenly have to switch to the other 2 pieces of content that it hasn't shown. So essentially, it'll continuously overshoot the uncertainty switch, which is what results in this kind of weaving effect of which content is being shown. We can go the kind of polar opposite to alpha equals 0.01. This is essentially forcing the model to be almost entirely exploitative. So we're giving it very little chance to just explore different options. And instead, it'll show a few pieces of content right at the start, try and find some key takeaways of how it thinks those contents perform to different users, and just pretty much stick with that for the duration of the week. There is obviously some switching, but broadly we see that once it picks a kind of relative proportion of the audience to show content to, it'll stick with that for the week. Quite nicely, if we go pretty much in the middle, we see both behaviors merge. So right at the start, we can see the model is in its kind of exploration mode, and we see this weaving behavior. And then as we move on through the week, it switches to exploitation, and we see more of that kind of identifying which segment of the audience it should send different content to, and that then impacting the distribution of impressions. So we didn't really get a kind of definitive answer from this in terms of what is the best value of alpha. But as I said right at the start, this was really our first sort of foray into the world of reinforcement learning, so a huge kind of learning resource for us. So while this maybe isn't going to go straight into production, this will help us a huge amount in the future when it comes to future tests and experimentation in how we pick this alpha value. So that said, we can look quickly at some of our next steps and also our ongoing work. So one of the big things that I've said was difficult was how do we pick that alpha value? And that's very difficult to do with just offline evaluation. So something we have been working on for a few months now is a proper sort of offline simulation approach. This should allow us to fully simulate the model without running it live on the website, which will not only allow us to kind of evaluate different alpha values and fine-tune those prior to a test, but it will also allow us to explore different policies and different models without necessarily requiring an A/B test for all of those. One of those models that we're interested in exploring is a self-tuning contextual bandit. So whereas currently we have to pick the alpha value, a self-tuning model would essentially pick that for us. It's somewhat similar to having like a learning rate scheduler in a neural network, where you'll start with some initial value, you'll learn as much as you can, and eventually that will plateau. And so the model then shifts that value to try and extract a little bit more performance. Another thing we're looking at is enhancing our customer context. The autoencoder that I briefly mentioned is currently not really tailored at all to this using content. It's something that we use across personalization. And so given the impacts of the user context in kind of providing the ability to personalize, we really want to explore ways that we can enhance that to extract as much signal as possible. Finally, we've only run one test so far, but we do have quite a number of tests in the pipeline. These will be testing in different placements on the website. Hopefully all of them will be better than the one we already tested. But this will provide us with a great view on the actual production value of this model and give us a lot more insight into how we can tweak things and explore new options. This is all I've got for you today. So thank you very much for listening. And I will do my best now to answer any questions.
How do you choose the people that you're going to show the variant website?
As in, how do we choose between the control and the variant? So that's done essentially entirely randomly. So this is normally quite easy to do on a website because we can just divide users based on hashing their user ID. So there's no kind of criteria for picking a user. They have to be kind of valid for personalization, since we can't do personalization if you're not. But the criteria for that is fairly minimal. So generally, when we were running this test, a user logs into the website and they immediately just get bucketed into one or the other randomly.
Okay, thank you.
First of all, thank you very much for a really good and interesting presentation. I've got two questions, and excuse my ignorance, it's possible I missed some information up front. The first one is the alpha, which I believe is a factor of how far you want to explore the horizon. Typically, that's between 0 and 1. If I'm correct, what was the intuition behind increasing that to 5? I'm not sure if you can explain that. So typically it should be between 0 and 1. Essentially, we really struggle to find any kind of reliable literature in how to pick this value. We found that in some kind of out-the-box implementations, it's set to 0.5 by default. But really, we just wanted to explore the impact that it had on the model. And with the kind of intuition that the higher alpha is, the more explorative the model is, we thought it'd be interesting to kind of push it beyond where it should theoretically go so that we can see the model perform in its kind of extremes. Okay, cool. Second question, again, might be obvious. I think you indicated that this is retrained every 15 minutes. And I just wanted to know, does this suffer from, or does that account for being able to mitigate against cold start, the very classical cold start problem with recommendation engines?
Yeah, so just to clarify, it's not, it's kind of updated every 50 minutes. I think you understand that, but just to clarify, it's not retrained from scratch, it's iteratively trained. But yes, this model does kind of inherently suffer from cold start. It's not something that we've been able to kind of really find a fix for so far. But essentially, yeah, every time the model is reset, which would have been once every week, you start off with 0 information. That's 0 information about the users, 0 information about the content, and that has to be just learned on the fly. So one of the things that we are really trying to target here is for that model to learn that behavior and reach a kind of satisfactory level of performance as quickly as possible. But yes, cold start is a big problem here.
Thank you. Good work.
Hello. I'm just wondering, how do you handle seasonality and target drift in this?
Yeah, so it's not something that we really have to consider too much. As I said, the content on across Tesco changes pretty much weekly, at the most 3 weekly, and the model will never run for more than a week. So seasonality shouldn't be too much of an issue since it will always be resetting. Long term, if we were to add kind of extra features, I mentioned at the start that in our current position, we aren't able to add like content context, so it doesn't know that it's meat or it's veg.
If we could add that, then that might also help with this. Perhaps we can have features where we might be able to identify that these are certain festive deals or something like that. But right now, it's not something that impacts the model too much, just due to the frequency that it's reset.
Hey, so from what I understand, you're optimizing the model to optimize engagement. So when we're dealing with e-commerce, my understanding is generally we're trying to sell things. When you're learning the reward, not the reward function, but the reward function, if that makes sense. The feedback from that to complete a full journey from hitting the website, being shown some content to actually finishing a purchase quite a long time. How would you reconcile that feedback loop, or the difference in feedback loop between making a purchase and updating the reward function?
Yeah, so even though we don't currently actively consider the purchase process, we look purely at clicks. It is still something that is difficult. Even ignoring purchases, the kind of window where someone views the content and then when they actually click it could be anything from like a second to 10, 15 minutes. We do have to essentially just pick a cutoff point. I think we currently set that to 15 minutes, so it all lines up quite nicely. We have done some kind of rough analysis of essentially how many events do we lose by cutting those off. There are going to be users that load the page, disappear for 3 hours and come back. But with a 15-minute window, I can't remember the number, but we capture a significant proportion of those events. In terms of then including like sales, that probably would be far too large a time span to include those as any kind of influence on the reward. But it is something that can definitely be looked at when it comes to analyzing kind of business impacts.
Thank you.
Hi. Yeah, thanks. That was really cool. Have you thought about kind of diminishing returns? Because I'm guessing this model is going to identify what to show, like this person should be shown meat, but then they would kind of consistently get meat. But I guess once you see it 2 or 3 times, maybe there's benefits to showing something else.
Yeah, so this is something that can be handled in 2 ways. So first of all, for that exact reason, we, to an extent, rely on like the quality of the content. If we ran this A/B test and all 4 of our options were just different meat options, that's not going to really help anyone because we go, you like meat, here's meat. That's not really useful. Ideally, though, we will be given content options which kind of cover a wide range of our product base. So there is the option of exploring different things. Secondly, the model itself should be able to react, not necessarily in real time since the weights will have to update, but if we see that users initially engaged with meats because they started clicking on it, and then we see that that drops off, that should impact the model weights such that it starts exploring other options because the expected reward for the meats, for the users that we showed meat to, will start to decrease. So it should kind of be handled by the model, but again, that's all very sensitive to exactly how we set up the model, and that's very much still something that we are working on.
Cool, thank you.
Hi, I have a quick question about, I do see the Kafka and the Flink. I'm just curious about the data lake. What tech stack do you use?
We use Azure primarily. I'm not sure how much I can really say. I had to remove stuff from the slides, but we use Azure.
Oh, pure Azure, or you also use like HDFS or something on-prem?
I don't know how much I can say. Yeah, we use HDFS and Azure and some other things. Yeah.
Yeah, great talk. One implementation issue that arose to me is you need history on your customer in order to be able to personalize what you're going to suggest to them. So that requires that you have your customer signed in, right? But the Tesco grocery page automatically lets you start looking at stuff right away. And then maybe by the time you sign in, you're just starting your grocery shop. Is there any way that you can get around that?
So yeah, this is definitely a problem we have to consider. When it comes to the A/B test, users being signed in was a criteria for being part of that test. So that kind of fixes the issue temporarily here. Long term, there's no kind of real easy approach to fixing like personalizing for users that aren't signed in. If you're not signed in, we don't know who you are. We can't really do anything more than recommending based on global behaviors. There are definitely ways, for example, we're using contextual banner here because we want to personalize. We could still achieve sort of optimized content orchestration that isn't necessarily personalized by using a kind of simpler multi-unbandit model. So that would just basically show content based on how stuff is performing globally. So that would somewhat address that issue, but there isn't really an approach where we can personalize without you being signed in.
Hey, thank you. Great talk. Just wanted to ask on the architecture diagram slide, one of the kind of, I forgot what they call it, inputs was the personalization API. So I was just wondering kind of what's returned in the context of this, the content orchestration. Is it like given user ID, return slot 1, slot 2, slot 3, or is it?
Yeah, essentially. I mean, I can't obviously like detail our architecture, but pretty much the personalization API is the team that will serve our model. So yeah, they will receive something like a user ID, pass that into our model. We convert that into that user embedding that I was talking about, actually then do the inference with that, and then we will return essentially a content ID, which will allow us to serve that suggestion on the website.
Cool, thank you.
Hi, great job, thank you. I was wondering if you could tell us a little bit more about the power of the experiments that you have conducted, because you're essentially tuning parameters and like running experiments with different parameters, and were they essentially, did they have enough power to conclude or like to reject
As in
the null hypothesis? Because what we found, at least in our company, is that even if you have like millions of like daily customers, like the delta as a consequence of parameter tuning is like not big enough to detect any effect. And if you didn't observe like any statistically significant results, then did you bundle, you know, certain changes or like sets of parameters together?
Yeah, so essentially, no, the statistical power was fairly weak. It kind of depends how you view it. From like our perspective, we're considering, like from the data science, we're looking at it week by week, because for our purposes, we're trying to get results on how the different alpha value performs. From like purely the data analytics side, it's still valid to look at this either in 3-week chunks or in 6-week chunks, since again, like refreshing the model every week is still a realistic use case. So typically 6 weeks on an online test should be enough to get decent statistical power. We did suffer here because of the fact that our model was running very low down on the page, so we did just not get that much engagement. The statistical power was not great here, but again, that's something that we will hope to improve with higher traffic placements.
Was the experiment conclusive?
In some ways, not in others. There's still a lot more testing to happen.
Did you think about optimizing those parameters on a customer strata level? Because from what I noticed in like this stuff is like you did it on a global level, but did you think that maybe like different cohorts of customers could benefit from different levels of like exploration/exploitation?
So it is something we consider, or sorry, could consider. We don't consider it right now. Dividing customers based on cohort is not necessarily an easy thing to do. We do have kind of ways of segmenting our audience at Tesco based on just kind of your shopping history. If you want to go further than that and start looking at like demographic things, those are basically features that we try not to touch. We try and infer any kind of segments. So just trying to kind of directly put that into the model is probably not something that we'd be looking to do.
Maybe it could be taken care of by the contextual bandit, potentially.
Yes, yeah, exactly.
Okay. We have come to the end of our content orchestration session. Give it up for Chris Wilkin.